Good morning, everybody. Today is Wednesday, October 14th, and today we are looking at proportions. I put an activity from Desmos. It's called Marcellus the Giant in Google Classroom. I'll make sure it's there. It is going to be under classwork. Yep, and it's called Marcellus the Giant. I want everybody to try and go through that activity so that you can kind of understand what proportions mean. That's what we're going to be doing in class, and then we are going to go through and talk about how proportions are used and what we do with them with tables like this. Okay, so a proportion is just equal ratios. So if I've got 10 to 2, and I say that is a unit rate of 5 to 1, since they are equal, they are proportions. So a proportion just means equal ratios. So on this it says complete the table. They say it is a proportional relationship, so complete the table. And they want the ratio of milk to eggs. So we go 6 to 2, and then they say that the next one, so that's 6 to 2, so the ratio we put in right down here is 6 over 2. Then the second one is 3 to what? We're supposed to be doing milk to egg, so I did that wrong. It would have to go, remember, the ratio is, come on, milk to eggs. So I don't know the milk, but I do know the eggs is 3. So we got to figure out, well, the ratio, if I simplify this down 6 to 2, I simplify that all the way down in simplest form. It is divide 6 by 2, I get 3. 2 divided by 2 is 1, so the ratio is 3 to 1 in simplest form, right? They told us that right here. So what we can do then is say, how do I go from 1 to 3? You multiply by 3. Multiply by 3, so that would be 9 cups of milk, because our unit rate was 3 cups of milk for every 1 egg. So if I've got 3 eggs, I need 9 cups of milk. Well, what if I've got 12 cups of milk? So that would go on top, milk over eggs. How do we go from 3 to 12? That would be times 4. So what do we do over down here? Multiply it by 4. So that would be 4 eggs if I got 12 cups of milk. Okay, so you're just filling in that table, and they're telling you it is a proportional relationship. This one says decide whether it shows a proportional relationship. So we got to figure it out. 25 over 5. And you should always, when you take these tables, you should always set them up as y over x. Seems backwards. It'll make more sense the further you move along in math. We'll get to all that stuff later. So 25 over 5. We want to, the best way to compare them is to simplify them. So, and when I say simplify, I mean turn it into a unit rate. So 25 divided by 5 is 5. So that ratio is 5 to 1. So I need to check to see if they are all 5 to 1. 30 divided by 6, is that 5 to 1? 35 divided by 7, 35, not 37, divided by 7, that is 5 to 1. And then at 40 divided by 8, that is 5 to 1. So since they all simplify down to the same unit rate, it is proportional. So you got to do the same thing here. Now what if I accidentally set it up the other way? What if I did y over x? 2 over 4. Well, if I just simplified that fraction, instead of turning it into a unit rate, it would be 1/2. So then I would just do that for all of them, 4 over 16. Just make sure you set them all up the same way. So that would be 1/4. Nope, they're not the same simplified fraction. So therefore, it is not a proportional relationship. I don't even need to finish it. Well, you could also have some with these wonderful fractions involved. You're going to go 150 over 30. If we simplify that down, we get, 5 to 1? Well, let's do the same thing over here. 5, 6 over 1, 6. Remember, I'm doing y over x, so that's why I did 150 over 30. Now do the same thing, y over x over here. And then I would have to punch this into my calculator. So I get out my handy dandy calculator. And I'm going to go 5 AB over C6 divided by 1 AB over C6 equals 5. So this one is 5 to 1. And then I just have to keep going and checking them all. All right. Now on this one, they want us to use our proportional relationship understanding to figure out how many squares there'll be if there's 75 ovals. So I got to come over here and count how many circles to ovals there are. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ovals to 2 squares. Okay, so I did ovals to squares. I'm going to simplify that down to 5 to 1. Okay, 5 to 1 ovals to squares. Well, what if there's 75 ovals? We're doing ovals to squares. So there's 75. Well, how do I go from 5 to 75? I can't just multiply these because 75 is not the bottom number on this. So I would go 75 divided by 5. 75 divided by 5 gives me 15. So that means that was a multiple, had a factor of 15. So we would multiply 15 over here as well. 75 over 15. So there should be 15 squares. So you're using these proportional relationships to help you solve some problems. All right, so you just complete the table. Just follow through with these. You should be good to go. And remember how I said you should set them up y over x because they're going to say all the ratios y over x, y over x. So you need to get in the habit of setting them up as y over x. So if we've got a table like this, how do I know which one's y, which one's x? Because it doesn't say y and x. The first row usually is your x column, will be your x column. The second one would be your y column. So I would put 22 over 1 on this because that's a unit rate. 22 square feet of lawn seed for every 1 ounce. 22 square feet is covered by every 1 ounce of lawn seed. So you need to figure out if that's proportional based on the rest of that. Okay, and there you go. You're just setting them all up. Y over x. To determine if they are proportional or use the proportional relationship to solve a problem. Make sure to do the activity Marcellus the Giant so you can see what proportional relationships mean in real life and how they're used. We got a quiz Friday, So tomorrow's Google Meet at 1:25, 1:30 is super important. I'll give you guys a sneak peek at what will be on the quiz. So see you tomorrow at 1:25.